Hi everyone, I'm Zainab Al-Maraj. I'm GDG's Kuwait lead organizer. And I'm so happy to see everybody here today. So this session is part of DevFest Kuwait 2020 series. It's event number 4. The main goal of our GDG or Google Developer Group is to share tech knowledge, skills for those who want it. Our workshops are free. Our goal is to ultimately make a difference in the tech community and also lead towards a stronger networking between tech people, collaborations, help build visibility for those who want it, and seek a solid tech platform here in Kuwait. So we're just under 3 years old. We welcome everyone to participate, talk, volunteer, and help grow our GDG. Today we've invited Rishit Dagli to take the stage and talk about machine learning. So Rishit is our youngest speaker yet. He's a grade 11 student, a TEDx and TED-Ed speaker. He loves sharing his knowledge. He mentors a TensorFlow user group Mumbai, organizes groups under Global AI Mumbai and also Kotlin Mumbai, where he's an international speaker. He also works at Google AI Explore ML as a facilitator. And he's interested in research and has published multiple research papers in the areas of AI and math. Cool, huh? He's also represented his country in various hackathons and competitions, and I'll share his social media handles in a little while. In today's talk, Rishit will provide an overview of the different tools one could use to power their Android apps with machine learning and discuss new additions to Android 11 specifically, and the model binding plugin and the MLKit. He'll also cover pre-trained models with the MLKit and pre-trained models with TensorFlow Hub. So you can run them in the applications directly. So without further ado, welcome Rishit to GDG Kuwait, and the floor is all yours.
Hi everyone. Thank you, Zainab, for the wonderful introduction. So today we'll be talking about how to superpower your Android apps with machine learning, all what is new with Android 11. Before I move any further, I have switched on captions from my end. You would see them under the slides over here. So it could possibly be a lot easier for you to follow along. So today we'll specifically be looking at the new additions with Android 11 for machine learning. So if you have worked with machine learning in Android earlier, I'll let you know newer ways of doing that, more efficient ways of doing that, and you'll definitely love it. If you have not worked with machine learning in Android earlier, today I will be walking you through to making your first Android app, which deploys a machine learning model on Edge. So you could try out all the things I show in this talk after the talk by yourself too. Hi everyone, I'm Rishit. Zainab already covered a lot of this, but I'm currently a high school student from India. I'm also a TEDx and TED-Ed speaker. I also love participating in competitions and hackathons, and I've also represented my country. I've published multiple research papers, and my coordinates are available at rishit.tech. So if you want to know more about what I do, feel free to check out this URL. Also, these are my social medias. So let's get started. But before that, first off, I would like to give acknowledgements and thanks to Syed Paul, who's a machine learning GD, Khan Leviat from Google, and Hoy Lam from Google, have helped me in reviewing these slides and putting together a better version of these slides. So let me just quickly tell you who the ideal audience would be for this talk. It would essentially be mobile developers who are looking for ways to build smarter applications. So if you want to build an application which does, just an example, there's a lot more you could do, but one of the most common examples, you want to make an application which could do face recognition or image classification in your Android application, this is the right talk you have come to. It would also be mobile developers who are looking for ways to integrate machine learning into their existing apps. So if you already have a machine learning team who has developed a model and you just want to integrate it in your Android app, this is again the right talk you have come to. We'll be discussing all of this. So first off, why care about machine learning in Android in the first place? I'm today here talking about machine learning in Android. So why should I be caring about it in the first place? So I'll not talk a lot about this, so we can get to the cool stuff very quick, which is how to actually deploy your models, how to make your Android app which deploys TF Lite models, but just a little bit of this, so we can get to the cool stuff very quick. I'm sure all of you know about how the number of Android devices have increased exponentially. I'll give you no numbers. All of you, I'm pretty sure all of you already know how the number of Android devices have increased exponentially and are also aware about how ML is revolutionizing almost every industry. So it makes sense to make this power of ML available to everyone. And well, how do I do that? I deploy them on mobile devices. So we already use products like Google Photos or Gmail, Gboard, and it's due to ML that these are so powerful. So today we'll also be talking majorly about on-device ML due to some reasons which we'll soon see. And Android 11 too has a lot of cool stuff for on-device ML. So most of the updates regarding ML in Android 11 are pertaining to on-device ML. So what's this hype about on-device ML or machine learning on edge all about? So the idea is to use ML such that, opposed to the traditional approach, I no longer send my data to a server or some cloud-based system, which then does the ML and then returns me the outputs. What I do is I instead get the outputs or inferences from my ML model on the device itself. That is, I no longer send data out of my device to some cloud hosted server or some server in general. Well, this also means you might have figured it out by now. I do all the pre-processing stuff, running the model stuff, the real inference stuff in the mobile device itself. So I hope all of you have a question at this stage, which is, okay, Rishit, you told me what machine learning on edge is all about, but why should I be doing all of this? Why should I be taking efforts to be doing machine learning on edge? So coming back to the question, why should you care about machine learning on edge? So the first thing that would come to your mind in a setting like this, which is running the machine learning model on the device itself, is power consumption. I spend a lot of power sending or streaming my data continuously to a server. And sometimes this becomes just infeasible to do so. So I love to take this example of a live video streaming application. Let's say you developed a live video streaming application or are planning on developing a live video streaming application. It would take a lot of power to continuously send a high quality live video stream and then receive the outputs. So yeah, this is something you would want to consider. But yeah, worth a mention, in some scenarios, the opposite could also hold true. It could happen that using machine learning on edge, you end up spending more power. This usually happens in cases where you have super heavy pre-processing steps. So it it could happen that you end up spending more power doing machine learning on edge, especially when you have heavy pre-processing steps. But usually, this is something you would want to care about. Another important thing to consider is the time it takes for me to get the output or essentially run the model itself. So how much time does it take for the model to run on one data point, let's say? For real-time applications, this is again a pretty important aspect to consider. So if you see, what am I doing in an edge setting is that I'm not sending the data to a server. letting the server do the ML and then getting the data. I'm not doing any of that. I'm doing the machine learning steps on the device itself. So in most cases, you also end up reducing the inference time because you no longer have to send data back and forth to a server or some cloud hosted system. And finally, this is expensive in terms of network availability. I should have the bandwidth and network to continuously send the data and receive inferences from the server. So again, the same application, which I would love to reference back again, is a live video streaming application. I would need to continuously stream a high quality live video stream and then get the outputs. I should have the network for doing that. This could prove pretty expensive in terms of network. So with the model on edge, that's no longer the case. And uh, so there's one more thing which I'd like to highlight at this stage. And I guess most of you might have thought about this in your minds by now. Security or privacy, as you may call it. So note that we are no longer sending data out of my device, right? I am no longer sending data to a cloud hosted system or a server. So what does that mean? I essentially am ensuring privacy. So there are a couple of more steps you would do to ensure privacy, but yeah, this makes up a huge chunk of the privacy part too. So that was so now I hope that you have uh, you have good reasons to be caring about on-device ML and machine learning on Android. So now let us discuss what Android 11 has for you to do all what we discussed. That is running the machine learning models on edge on the mobile phone itself. One of the most coolest updates is the model binding plugin. So a lot of you can make a pretty good guess of what this would do from the name model binding. So you can make a pretty good this. So what the okay. So before I move any further, just a note: you need Android Studio 4.1 or above to be running the machine learning model binding plugin or the ML model binding plugin, as you may call it. So the ML model binding plugin makes it super easy for you to use a TensorFlow model in your application. You essentially have a lot less code to write, and you so yeah have a lot less code to write, which actually calls the TensorFlow Lite Android support library. You can import a TensorFlow Lite model, read the input-output signatures of the model, and finally use the model itself with just a few lines of code. And yeah, which is pretty good. We'll soon see that how does the fact that I mentioned just a few lines of code work out. So we'll soon see that how the code works out and how to do this in practice. But for now, take me when I say it takes just a few lines of code and it's very easy to use. Another thing which I love about the model binding plugin is you can easily make use of hardware accelerators. So I can easily make use of GPUs, let's say a GPU accelerator with the model binding plugin. So with the model binding plugin, using hardware accelerators has never been easier. So let me give you an example. So if you have an existing application and uh, in, you want to be using GPU acceleration in it for running the model, you need just a one dependency call, and one line of code. That's how easy it is to use the GPU acceleration with the model binding plugin. Just one line of code. So that's really something I love. And it also makes it very easy for you to do even more with the neural network API. So you can do even more with the neural network API and the model binding plugin. And of course, this would make your development a lot more faster. With the features we just talked about, your development would be a lot more faster. You have easy support for integrating your models. So I told you a bit about how this all works out, but let's actually see this in practice, how you would be doing it for a application you want to make. So first off, I want to import a TensorFlow Lite model, right? There's where that's the model itself. So I, of course, want to import that. So the first step is to import a TensorFlow Lite model with metadata. So Android Studio now has this new option for importing TensorFlow Lite models. So I don't know if you can see it clearly on the slides over here. If you can't, I'll read it for you. So just right click on the module you want to import the TensorFlow Lite model in, and you'll see and now you'll see a new option called TensorFlow Lite model. So here the slides just show the same. I have highlighted the TensorFlow Lite model text in red, which just shows that I have this new option called TensorFlow Lite model when I try to import something in a module. So once you click this, you'll have a window which allows you to pass in the path for your TensorFlow Lite model. So on the very above, I have a text box where I can simply pass in the path of my TensorFlow Lite model. So what the machine learning model binding plugin will do for you is the TensorFlow Lite model which you have passed in, it will create a directory for you inside the module, and the directory will be named ML, and the model will be imported inside this directory. So yeah, a directory called ML will be made in the module where the model will be imported. And also this is from where you will be using the model in later stages. So I again don't know if you can see it very clearly on the slides over here, but I'll read it for you. I have a checkbox over here called automatically add TensorFlow Lite GPU dependencies. So again, uh, remember I told you GPU dependency is one dependency call and a single line of code away. That one dependency call is just a click away over here while importing your TensorFlow Lite model. So now what I can do with Android Studio is I can open the TensorFlow Lite model in Android Studio. So in most cases, this will be as simple as double clicking the TensorFlow Lite model. You just double click the TensorFlow Lite model and it opens in Android Studio. And what it displays over here is the model metadata. So why am I showing you all of this? That it displays the model metadata. So model metadata is a pretty important and uh, useful document, you could say. You can see a lot of stuff over here which you need to actually use the model. So I have input output shapes over here, description of the input, so what would my input look like, and so on. I can also say, okay, I need some more description about the model. I need the license under which the model is made. I can get all of that from my model metadata. So before we move any forward, uh, the things which I'll be showing now are well applicable for all kinds of models, for your own models too. But I love building something on the go. So while we do this session, I would love to build something. So what we'll be doing is we'll be taking an example. We'll be deploying an open source model made by me. So what that model does is it classifies between rock, papers, and scissors. So you show the camera rock, papers, and scissors, and the model will classify it. So I made this open source model, and we'll be working on deploying this. So again, all of what I'll be showing will be applicable to other models, your own models too. But I like to build something on the go. So we can build something on the go. That's why we'll be taking an example to do so. So let's finally start using the model. So before I actually go on to telling you how to use the model, a simple convention I'll be using for the rest of the talk, which is I'll call the RPS rock paper scissors model, which I just told you about, as the RPS model. So I'll be using this short form for rest of the talk. I'll be calling the RPS model in short. Oh, sorry, rock, paper, scissors model as RPS model. Yeah, so let's finally start using the model. So for a streaming inference, which is most probably what you would want to do, live image classification, as you may say, the easiest way would be to use camera X and pass in each frame to a function which can perform the inference or run the model. So in this talk, what I'm interested in is the function which actually runs the model, which actually performs the inference. You'll see how easy it is to do this. A sample code for this is also seen when you import a TensorFlow Lite model, which you can use. So first off, remember I had imported the model called RPS model.TFLite. So once I import that, what the model binding plugin will do for me is it will create a class of the exact same name for me. So a class of the exact same name, which you can see over here, RPS model, a class of the exact same name is created for me. So first off, I'll start by instantiating a RPS model or a rock, paper, scissors model and pass it with the context. Yeah. So after this, I want to convert my data into a form which we can use. So remember what we are doing over here. We are using camera X to take in live video input and then passing in each frame from that live video input to a function. And that is the function we are looking at currently. So I want to change my frame into a format which I can use, I can perform inference on. So currently it's in an image proxy and I want to change it in a format so I can perform inference on it. So we'll convert it into a tensor image and this will be from a bitmap. So folks who use TensorFlow interpreter before, you know that you need it at this stage, you needed to convert your image or frame to explicitly to byte arrays. You no longer need to do that. You no longer need to do that with the machine learning model binding plugin. It does all of that under the hood for you. So again, makes the stuff pretty easy. I've just converted it into a tensor image and showed it into TF image. So now we'll pass in the data and actually do the inference. So don't get intimidated by this code. It's super simple. We'll take this line by line and you'll be able to apply it on your own models too. So first, I want to process my image or essentially run my model on the image. So what I'll do is I'll just use the dot process method from the RPS model with RPS model object we created. So I'll just have a dot process, pass in the TF image. So the TF image is what I created in the line above this. I'll pass in the TF image, and that's how you do the inference. So with this, what you essentially get is an array of probabilities. So what is this array of probabilities all about? So what you're doing over here is you're getting the inference from your model. So in this case, I had three labels, rock, papers, and scissors. So what my array of probabilities will be an array with three elements. So one of those elements will tell me the probability that the model thinks it is a rock. Another one will tell me the probability that the model thinks it's a paper, and so on. So that is essentially what I'll be getting from this. So a thing I would like to tell you before I go on any forward is I'm doing a couple of processing steps on the output over here. You definitely do not, you definitely are not uh, forced to use the same processing steps. It's an array of probabilities. You could do whatever you want. So it's pretty much up to you according to your business use case what you want to do with these array of probabilities. In this example, to build a complete end-to-end example, I'll be showing you a sample transformation step, which you can use for this application. So what I'm doing over here is I'm performing a descending sort. As in this example, I want to show the user the label which has the highest probability first. So if a user shows the model a rock and the rock has the highest probability, I should be showing the user rock first, and so on. So again, over here, you are not forced to use the same thing. Let's say, I don't know why, but you want to choose the label which has the lowest probability. Let's say let's say you want to do that, or let's say you want to choose a label with some other criterion. You can very easily do that. It's an array of probabilities, anything you can think of. After this, what I also want to do is I want to take the top few results, or the top n results, as I like to call it. So I want you to remember the model which you are using here. You're using a rock, paper, scissors model. It has 3 labels. And that's not a huge number of labels, no big problem. But let's say if you're using a model which has 1000 labels or even more, you don't actually want to show all of these labels to a user, or you don't actually care with all of these labels. Maybe you care about just the top 5 labels or the top 10 labels, anything that your use case needs. So you can simply specify it over here. In this case, it's just 3 labels, so nothing great to worry about. Finally, I'll add the label corresponding to each entry in the outputs to show it to the user. Because, well, I also want to show my label and the score, the probability, back to the user. So that's what I'm doing over here. And that is pretty much what you need need to do inferences with the model binding plugin. So yeah, super simple. I remember me telling you it's just a few lines of code. Now you can see it yourself. Just a few lines of code, and you used a machine learning model in your Android app. Isn't that pretty cool? So yeah, that was about the model binding plugin and how you can use it for your own use cases too. What I also want to show you before I move to the next update with Android 11 is that, remember me telling you enabling hardware acceleration is super easy. So let's take an example and see how you can do hardware acceleration with the model binding plugin. So I'll show you how to do GPU acceleration. So first off, I'll make an options where I specify it to use GPU. So model.device.gpu, that is essentially me saying, okay, you need to use the GPU. I'll build it, and at the stage where I instantiate the model, I will simply pass this as an argument, a part of the context. So that's pretty much what you need to enable GPU acceleration in your Android app. So again, I feel this is pretty cool. One line of code, as I promised, for GPU acceleration. It is also the model binding plugin also makes it very easy for you to use the neural network API for acceleration and to do even more. And with Android 11, you have a lot of cool updates to the neural network API, which I would definitely recommend someone to try it out firsthand if you're interested in the field, including asymmetric in-rate weights and a new quality of service API. But I'll leave all of that for some other talk as I'm running out of time. And yeah, let's talk about the other coolest update with Android 11, another major development with Android 11 for machine learning, which is a newer MLKit. So I guess a lot of folks here know about MLKit or have used MLKit. If you have not used the MLKit earlier, let me just give you a brief about the MLKit so you can better understand what we'll be talking. So MLKit has a ton of a large number of state-of-the-art pre-trained models for you, which you can use right in your Android application. So these are the examples of the services that MLKit allows you to do out of the box in your Android application. And it's very easy to use MLKit to do all of this with your Android application. So this year we also have two new model updates with the MLKit, which is digital ink recognition and pose detection. So, but yeah, you can at this stage you can just know that it's a huge uh, it's a huge collection of state-of-the-art pre-trained models which you can use right out of the box in your Android applications. So let's see what is new with the MLKit and how you can best use it. So before I move on, telling you what is actually new, one of the things which I'd like to highlight at the start is MLKit is now available to use even without having a Firebase project. You can essentially now use MLKit even without creating a Firebase project. Okay, so let's move on. As I said earlier, a lot of these updates, majority of the updates with Android 11 for machine learning are focused on on-device ML due to the benefits which we talked about. The new ML kit now has better usability for on-device ML. And we'll see how it all works out, how you can actually use on-device ML with the new ML kit. The ML kit image classification and object detection and tracking models now also support custom models. What this means is you can have just a TensorFlow Lite model which runs on top of the state-of-the-art pre-existing models by MLKit. So I can have just a TensorFlow Lite model which runs on top of the state-of-the-art pre-existing models and gives me better customizability. So what this also means is what I really want to highlight over here is if you're working on some generic kind of use case. So let me give you an example. If you're working on image classification, a specific kind of image classification, let's say I'm working on image classification with, oh, I cannot come up with good. Okay, yeah, one good example I came across. Let's say you're working on humans versus horses. An example, just an example. You could do pretty much any kind. You could take up pretty much anything. Machine learning folks here might be, oh, I have heard humans versus horses somewhere. Yeah, it's a open source data set, pretty famous. I just reference it over here. So yeah, let's say you're working on horses versus humans object detection, which is a kind of generic use case. Uh, so what you can do is you can use the MLKit object detection models and run your own TFLite model on top of it. So if you're working on these kind of uh, generic use cases or a specific kind of object detection, what I just showed an example to you, MLKit is the best thing to use. You should definitely be using MLKit. So let's actually see how you put this into practice and how you can start using it. So again, this is well applicable to all other models. This is well applicable to your own model, but I like to build something. So we can build something while I give this talk. So what I'm making over here is a food classifier application. So you just show some food to the camera and it should be able to classify it. So I'll first start off by setting the model file, the TFLite model file. So a note over here, a lot of you might have already kind of guessed this, but you can see I have a .set asset file path. So yeah, the TFLite model should first be added as an asset, and then you can use this. So again, this model, this TFLite model, will be running on top of the object detection and tracking model with MLKit. So what this means is you have limited customizability because, well, your model is running on top of another state-of-the-art pre-existing model. So you have a little bit less customizability, but still there are some great options you can go ahead to customize. I've shown a few examples over here. Let's take a look. So first off, I have a detector mode. So which is essentially saying the same thing. I want to do live image classification. That is, I want to be using the streaming mode. So that is what I've specified over here. I also have a classification confidence threshold. So I'm saying that my confidence threshold should be 80%. So you can work around, you can try working with different numbers over here for the confidence threshold and you will get a hang of it. But yeah, these are the some of the options that you can customize a bit. So let's get to the part where we actually run the model, perform the inference. Again, don't get intimidated by the code. We'll take a look at each and every line of the code and you'll be able to understand it and put it to use for your own models too. I also would like to just make a note that you might see some syntax here similar to the previous example. So first off, let's take the inference part. I again process my image, which is essentially running my model. And then I have these three listeners, which are on failure listener, on success listener, and on complete listener. So what this is essentially telling me is, first off, I need to run my model, that process on the image. Once I do this, if my model failed in doing so, I write something to the debug log. So I have these three dots over here. There was some text over there. So I write something to the debug log saying, okay, this is the error. Once that's, if that's not the case, then my model might have succeeded. So once my model succeeds, what do I want to do? I want to maybe drop bounding box around the detected the detected item and show it to the user. So, well, how do I do that? I've just added some simple, I print out something on the graphics overlay. I draw out something on the graphics overlay and show it to the user. Once this is done, which is my model either failed or model either succeeded in doing so and showed the results to the user, I have a non-complete listener. So once all of this is complete, I'm simply closing the image proxy. Super simple code. A thing which I want you all to know over here is all of these are essentially tasks. So the on failure listener, the on success listener are essentially tasks. So they need to be attached for every single run you do. And again, that is pretty much what you need to do with MLKit and start using MLKit for your own models. Just a few lines of code, as you can see over here, and it's super easy. So, uh, so we talked a lot about what to do after TensorFlow Lite model, but let me talk a bit about how do you go about the TensorFlow Lite model. I'll not talk much about this since I'm running out of time, but you can build great models with TensorFlow Lite Model Maker. The TensorFlow Lite Model Maker was announced by the TensorFlow team just in 2020. And remember the rock, paper, scissors model we made, the rock, paper, scissors application we made, I should call that now. Uh, so the rock, paper, scissors model I made for the application was built using TensorFlow Lite Model Maker. So TensorFlow Lite Model Maker is super easy to get started with, allows you high performance, allows you to make high performance models and allows high customization too. Another place where you could find great models is TensorFlow Hub. TensorFlow Hub is essentially an open source repository of well-documented state-of-the-art models. So remember that food classification app we made? the food classification model was essentially taken from TensorFlow Hub. So give TensorFlow Hub a look. In most of the cases, you might just find the right model for your use case on TensorFlow Hub. And on TensorFlow Hub, you also have these cool filters saying, okay, I want models, I want TensorFlow Lite models only. I want models which can be run on mobile devices only, and so on. So it's pretty cool. Give it a look out. And what TensorFlow Hubs also allows you to do, which I love the most, is you get to use models from the community. So yeah, these are not just the only publishers on TensorFlow Hub, but these are the only publishers I could fit in a single slide. So yeah, you essentially get to use models from the community. I also have a couple of models on TensorFlow Hub. Feel free to give them a look. With that, enough of talking. Let's get to code and let's see live demos. So everything we talked about today is implemented in this GitHub repository for you. I made this GitHub repository specifically for this talk. It also has the source code which I used to create the TensorFlow Lite models. I would urge you to take a look at this GitHub repository. So if there's this one URL or one source you want to go back to after this talk is over, it should definitely be this GitHub repository. So maybe I'll give you a moment to note it down or take a screenshot. Maybe one of the organizers could also paste it in the chat. I'll just wait a moment so you can make a note of this GitHub repository. Let me also paste it in the chat. Yeah, here it is. Oh, thank you. So what I'll be doing now is I'm quickly switching my screens. So hang on with me for a moment. Okay. And here it is. I hope you can see my screen now. So here is the GitHub repository I talked about. It has both of these apps we made today implemented right for you. And yeah, if you just want to try it out, I also have the APK versions of these applications in the repository. So let's say you just want to try it out on your mobile phone, directly download the APK and try out right away. So let's see the code itself. Okay, so here I am in Android Studio. I hope the font size is good enough for you to see. And I've also switched on the light mode, so you could see you could maybe make better sense of it. Okay, so first off, note this is the function where I essentially want to take a look at this analyze function. What this does is essentially runs the model itself, gets me the inferences. So first off, I want to instantiate my model. So my model was called RPS model.TFLite. Well, I can also show it over here. Let me do that. That would actually be better. I could show it over here, what my model looks like. Let's open up app. So I know you might not be able to see this very clearly, but I'll read it for you. No problems. So remember I had told you that it creates a directory called ML in the module. So there's this directory. If you can't read it clearly, the directory name, as I can see over here, is ML, and inside which I have RPS model.tflite, which is the model I use. So the model name was RPS model.tflite, and a class of the exact same name was created for me by the model binding plugin. So if I double click this, I can also see the model metadata over here. But yeah, let's get on to the yeah. So here I'm simply instantiating the model. Then I need to convert my data into a format which I can use. So we had discussed about tensor image. I'll pass in an image proxy and convert it into a tensor image. So that's what I'm doing over here. Finally, it's time to actually make the inferences. So I'll use the dot process method and I'll use that on tensor image. So I just made a variable over here, TF image, which has the image proxy converted into a tensor image, and I'll do the process on it, which will essentially give me the outputs. Then, as I said, you could do any processing step over here. It's an array, all up to you, all you can think of. But for simplicity and demo purposes, I'll be performing a descending sort over here, and I'll be taking the top few results to show to the user. Once that's done, I also want to show this to my user. So I'll simply be adding the output labels and the output scores, which I could display to the user. So let's actually move on to live demos. Let's see this in action. So what I would have loved to do is shown this on an emulator, but well, I could show it in a real mobile device itself. So why do it in an emulator? Let's see an example of this in a real mobile device. Okay, that's odd. Give me a second. I guess I'll just do a retry. Okay, yeah, it's live now. Yeah, you can most probably see my mobile screen onto you. So you might see some latency in what I am demoing now because, well, I'm live streaming to you all and also wirelessly showing my mobile screen to you all. So you might see some latency, but the real application has almost no visible latency. So I hope my keyboard can make a good background. Yeah, that's my keyboard. Great. Let's hope it's a good background. And let me put something in front of it. So a rock. That's a rock. And give me a moment to see the results over here. Okay, I see it's almost 70% sure that this is a rock. So I feel that's pretty cool what my model could do. So I'll switch back my screens, and you also kind of saw a live demonstration of how our app performed. So with that, that's all I had to talk about the machine learning model binding plugin, the new MLKit, how do you do machine learning in Android. So with that, I'm done. Done for the talk. And if there are any questions, and I have the time, I'm running a bit over time. So if there are any questions and I have time, I would love to take them. So I'll leave that up to the organizers.
Thank you, Rishit, for that enlightening talk and the details that you shared. So I thought the examples were, and I love how simple you made the beginning examples in TensorFlow Lite, so the viewers can actually just walk away and try them straight away without any complexity or difficulty. I also really got intrigued of trying that TensorFlow Hub. This is the first time for me to see that, so I will check it out personally. And the demo was also super. So thanks for sharing those. I've been looking at our question and answer section, and I haven't seen any exam questions up to now. And so I'll elicit, please ask your questions away. Rishit's here for the next few minutes. And if we don't get any questions, then we'll be ending our event, which has been very, very cool. So what's your takeaways, Rishit, in terms of this? What would you tell the audience? Where could they get started if they were new to this type of stuff?
Oh, yeah. So as I said, if there's one thing you want to refer back to after this talk, it will definitely be the GitHub repository. So go to this GitHub repository, which I just shared. It has, so not only does it have the example which we talked about, so it has this pretty cool explanation I've worked on. It took me a lot of time to write it out, but see the README. It has pretty cool explanation. It explains each and every line of the code. So that's a really good way for you to get started. I explain each and every line of the code in brief. So you can definitely get a very good idea from them. And that's how I would also recommend you to start. As an example, if you want to do something more to this, so first take a look at TensorFlow Hub. Find a model at TensorFlow Hub which interests you. So when I went to TensorFlow Hub, I found the model food classification model which interested me, and I made a demo out to you and showed it to you. So find a model which interests you, use everything that we talked about, and simply make an application for that model. So that would be wonderful for you to get started with.
It's excellent advice, and I totally think as well that that's the best way to go. There's so much out there on the web that sometimes we're not sure where to look, and this sounds very simple. Thanks for sharing those feedbacks and input and recommendations. And I'd like to close today, given we don't have any questions from our audience. One note to let you go: don't miss our iOS application development workshop that's going to be Monday night at 7. There you'll find Midhat Suleimani, who's going to run a hands-on interactive code lab, and you won't want to miss that one. Also, I'll share the GDG Slack link and YouTube again in the chat. We have an active Slack channel, basically just to get people to network a little bit more. We share. Let me post you. Cool. Thanks for joining, and have a great evening to everyone. Thanks, Rishit.
Thank you. Thank you. If you have any more questions, feel free to catch me on any social media and simply ask it out.
Yep, I've posted them for the audience, so they should have got them.
Oh, thank you.
You're welcome. Take care.